You've probably seen Wi-Fi networks with hidden SSIDs, the ones that don't show up as a network name, just a blank or unknown entry. Network admins sometimes hide SSIDs thinking it adds security. It doesn't. In this lecture, we're going to uncover the real name of a hidden Wi-Fi network. We'll see exactly why SSID hiding is security theater, how to spot a hidden AP in airodump-ng, how to passively catch its name if a client connects, and, when no client is present, how to brute force the SSID using a tool called MDK4. Let's understand what hidden SSID actually does at the 802.11 protocol level. Because once you understand this, you'll see immediately why it's not security. When an access point hides its SSID, it simply broadcasts an empty or null SSID in its beacon frames instead of the real name. The beacon itself is still there. The AP is still advertising its presence constantly. Every 100 milliseconds, it's sending out a frame that says, "Here I am, here's my MAC address, here's my channel, here's my encryption type." The only thing missing is the name. And that's the fundamental problem. Look at the right column. 3 reasons this fails completely as security. First, the BSSID is always broadcast. We already know this AP exists. Airodump-ng shows it immediately. Second, the moment any client connects to this AP, the real SSID appears. When a client sends a probe request or an association request, those frames contain the SSID it's connecting to. Any attacker passively watching in monitor mode sees the name immediately. Third, if no client is around, we can brute force the name. We send probe requests with every candidate from a word list and watch for the AP to respond. When it does, we have the name. The 2 boxes at the bottom summarize the approach. Passive, wait and watch. Free. Active, brute force with MDK4 when no client shows up. Black bar at the bottom says it plainly. Hidden SSID provides 0 real security. First, we need to put our wireless card in monitor mode and scan the wireless interface. So, on your Kali Linux, open a terminal and then run sudo airmon-ng start WLAN 0 to put the Wi-Fi card in monitor mode. Now launch airodump-ng with the full recommended flags. Just look at the highlighted network. It has 0 length in the ESSID column. That's airodump-ng's way of telling you this AP is broadcasting a null SSID. That's our target. Note the BSSID and the channel. Here's one thing to remember. In the bottom section, we can see the clients connecting to the respective APs. When a client connects, it sends a probe request frame that contains the SSID it's looking for. The AP sends back a probe response and later an association response. Both also contain the real SSID. If this happens, our hidden AP name will show the real access point's name. But we don't have to wait for a client, and in some cases there may not be any clients at all. Then, we have to resort to active attack. Hidden SSID brute force with MDK4. Before we run MDK4, we need the right word list. And this is where a bit of intelligence makes the difference between a fast hit and a very long wait. Look at what we already know from the scan. All the other networks in range follow the same naming pattern: Wi-Fi it, Wi-Fi management, Wi-Fi offices. Every single one starts with the keyword Wi-Fi. The hidden AP almost certainly follows the same convention. So instead of throwing a raw word list at it, we prepend Wi-Fi to every entry. Use the command as shown on screen. Cat reads the original word list line by line. A WK processes each line and prints Wi-Fi followed by the word. So free becomes Wi-Fi-free, admin becomes Wi-Fi-admin. The result is piped into a new file called Wi-Fi-rocku.txt. We will use second wireless adapter for the MDK4 attack. Put the second adapter into monitor mode. Then, fix it to channel 11, the hidden AP's channel. If the adapter is hopping channels, it won't be on channel 11 when the AP responds, and you'll miss the hit. Use sudo iwconfig wlan1 mon channel 11 command to do this. Now, we are ready to launch the brute force attack. Use MDK4 and provide it with our wireless interface, the target MAC address, and the word list we just created. The P flag specifies the probe mode. This tells MDK4 to send 802.11 probe request frames using each SSID from the word list as the target name. Watch the output on screen. MDK4 cycles through candidates one by one. And here it find it. The hidden SSID is Wi-Fi free. The AP gave itself away the moment we sent a probe request with the correct name. It responded as normal, and MDK4 caught it. To connect with the hidden network, we can click on the networking icon in the top right toolbar. Now, select Connect to a hidden Wi-Fi network. Select your wireless adapter and the security parameters for the target network. Click on Connect, and we are connected. If you use ifconfig command, you can now see that you have got an IP address from the network. Now, open a browser and browse to AP's IP address. Try logging in with default credentials, which are admin for most APs. And we are in. Here's the complete attack flow on one slide. Step 1. Put wireless card in monitor mode with airmon-ng. Step 2. Run the full airodump-ng scan across all bands. Step 3. Look for zero length in the SSID column. That's your hidden AP. Note the BSSID and channel. Step 4. Lock airodump-ng to that channel and watch passively for clients. If a client connects, the SSID appears automatically. Done. No need for steps 5 through 7. Step 5. If no client, build the word list. Use AWK to prepend the naming prefix you've observed across other APs in range. Step 6. Start the second adapter in monitor mode and lock it to the same channel. Step 7. Run MDK4 in probe mode against the target BSSID with your word list, and it will find our target network name. That's it for this lecture. We covered how hidden SSIDs work at the protocol level, why they provide no real security, how to spot them in airodump-ng output, how to catch the name passively when a client connects, and how to brute force it actively with MDK4, and a smart custom word list when no client is around.